Hi, I'm Ben Zabback, and today I'll be talking about our planning for the ME2110 design competition. In this competition, we were tasked with creating an autonomous machine to complete various competition objectives within a given time frame. To create our design, we used various design tools, including the House of Quality and various charts, as well as some planning tools, which we will hit on later in this presentation. The first step was creating our House of Quality, which compared customer requirements, mostly from the competition requirements, to engineering requirements to find the most important ones. From this, we found that the three most important engineering requirements were having an effective sorting device for sorting the gems and nifflers, having an effective method to detect the drop of the center pipe for depositing Grindelwald, and having a method to egress the entire machine and stop all motion after 40 seconds. Next, we created our spec chart, which lists specifications for our final machine. We found that the most challenging specifications to meet would be first the geometry constraint, that the entire machine fit within a 2 by 1 by 1.5 foot box. Also that the machine can operate completely autonomously. We also found that it would be challenging to create a machine with a cost not exceeding $100, as this limits us a lot in terms of materials we can purchase, and creating a machine within the 4-week time frame given by the project. Next, we created our function tree, which breaks the competition tasks down into 5 main subtasks, 4 for dealing with each of the game pieces, and a 5th for retracting our machine to increase our total points scored. We found that the most complicated task was imprisoning Grindelwald, as this involves moving to the barrier around Azkaban, detecting that the barrier retracts, moving to the target for Grindelwald, placing Grindelwald, and then moving away from the target again. From the function tree, we generated a morph chart which lists 3 design concepts for each of the 13 bottom-level functions in our function tree. From this, we found that many of the tasks in the competition are somewhat redundant and can be performed by identical machines. For example, the 3 tasks related to the gems are very similar to the tasks related to the nifflers and can likely be performed by a single machine capable of doing both. Once we had a good grasp of the design, we could move on to planning our project. We began by creating a tree diagram which breaks down all the tasks needed to create the final design robot into smaller subtasks that can be assigned to each member. This tree is not very evenly balanced in terms of workload. For example, creating the final prototype, although only about a 1/5 of this tree would represent the vast majority of the work for completing this project. Next, we created a matrix diagram to assign responsibility to each of our 3 team members. What we found from creating this matrix diagram was that although some of these smaller subtasks, such as building the House of Quality, can be assigned to individual members, certain large tasks like creating the prototype, working on CAD models, are such large tasks that they cannot be subdivided for each team member, and because the team is so small, it would be counterproductive to assign even smaller subtasks within those tasks to individual members. The most efficient way to do it would be to have each member contribute their full energy to creating the prototype or creating the CAD model. Finally, we created a Gantt chart to put a schedule to our planning, and what we found from this was that because the timeline of the project is so compressed, it doesn't make sense for teams to create machines that only deal with one subtask that's assigned each week. The better option would be to have the team design the entire machine in the first 2 weeks of the project, and then spend each week implementing the subsystems until a final machine is ready for the competition.